Hello, everyone. My name's John WORMSLEY, and I'm going to talk about the European spallation source as a case study in developing a business case for an international research infrastructure. So I think we all agree that scientific and technical innovation is essential if we are to address the biggest problems that we face. These include the global challenges of energy and climate change, environment, and healthcare, where it's not enough to roll out existing technologies and demand broader societal adjustment. Our toolkit is simply not sufficient to solve these problems. And it's also essential if we are to address the economic and societal challenges driven by stalled productivity, long-term wage stagnation, combined with an expected post-COVID economic shock that we've yet to fully experience. I don't think anybody really has the answer to this second set of challenges, but we do know for sure that innovation and scientific and technical skills will position economies and societies better to weather these challenges. And if there's one thing we've seen over the past year, it's to re-emphasize the importance of scientific capacity and scientific capability in dealing not just with the challenges we know about, but with unexpected challenges as well. So research infrastructures have a really key role to play as national and international scale investments in shared research capability that go beyond what any single institution or even any single nation can support. They dramatically increase our scientific reach and help address scientific questions of long duration requiring pooled effort like those I listed on the previous slide. They also promote collaboration and interdisciplinary working and interaction with industry. But as billion-dollar or euro scale investments, they attract a great deal of scrutiny and they require a robust investment case, a robust business case, and an international pooling of resources. So back in 2016, when I was chair of the European Strategy Forum for Research Infrastructures, we reviewed the implementation progress of the projects on our roadmap, especially those that had been there since 2006 without successful implementation. And we found that inadequate stakeholder engagement and lack of a credible funding plan to be the biggest barriers, much more than any weakness of the science case. And that points to the important areas of the business case that must not be neglected. So the key challenges in building sustainable support for any science mega project, and especially for an international research infrastructure, are a solid science case, technical R&D to enable the cost estimates to be well enough understood, a solid project management plan, a credible funding and governance plan, good stakeholder engagement, and a compelling investment case, including, of course, an understanding of the anticipated societal benefits of the project. And the decision-making context in which that business case is going to be reviewed has undergone a significant shift, especially since the end of the Cold War. We used to think about mega science and big science as delivering cultural value, qualities like science for peace, promoting openness, democracy, and international collaboration. But much more nowadays, decisions will be made on the contributions to prosperity, to jobs and innovation, to sustainable development goals, and to the contribution that science can make to drive economic growth. And scientists may still be more comfortable on the left-hand side of this Venn diagram because that may correspond more to the reasons why they individually choose to work, but the investment decisions and government commitments will be made on the right-hand side, and it's important to understand that in constructing the business case. So for ESS, that business case was based on materials and molecules. And as a neutron scattering facility, ESS can answer the question, where are the atoms and what do they do? And that's key to understanding new materials and new drugs, new chemical processes, food, engineering, energy capture and storage technologies. So very topical examples of neutron research that's being carried out right now include understanding lipid nanoparticles that are used as a delivery mechanism for mRNA, a therapy for COVID-19, and understanding materials for future electric vehicles as part of initiatives like the European Union's Battery 2030 project. This is a picture of ESS, which is now 75% complete, and the layout of the facility follows its function. starts with a superconducting proton accelerator that accelerates a beam of hydrogen atoms up to roughly 1 GeV in energy, 90% of the speed of light. And when complete, this will be the world's most powerful proton accelerator. That beam is directed onto a neutron production target, and the spallation in the facility's title is simply the name of the nuclear process that releases neutrons from the target nuclei. 15 beams of neutrons are then directed onto 3 sets of experimental halls in the buildings shown here, and the other facilities provide offices, maintenance laboratories, and utilities like electricity, cooling water, and cryogenics to operate the facility. The scale of the investment is roughly 3 billion euros up to 2025. There will be 15 experimental stations, each on average 20 times more sensitive than today's best facilities anywhere else in the world. And this will enable 800 experiments to be done per year, each roughly 2 to 3 days duration, for thousands of European scientists. The facility is constituted as a European Research Infrastructure Consortium, or ERIC, which involves 13 member countries that are shown shaded in the diagram on the right. And the facility itself is located in Lund in southern Sweden, which is the orange dot. Now, of course, the science impact of the facility is the key deliverable, but that can't be measured in advance. So the business case is based on the relevance of the research, current European strength in these areas, the ability for ESS to do dramatically better, as is shown by the brightness of the neutron beam in this chart on the left, and the involvement of key industry partners to make that case. So it's not simply scientists arguing in support of investment in science. As an international facility, one of the key ways in which ESS is constructed is to make use of in-kind contributions. These are significant technical work packages that are procured or constructed in the partner countries rather than centrally. This means the partner holds the budget and spends the money locally, but they also have to manage the risk. This is a project management challenge, especially ensuring installation and integration of this diverse supply chain, but it's a political necessity. It enables you to exploit the strengths of national laboratories in the partner countries. It spreads the economic benefit and avoids a situation where the host region benefits from everybody else's spending. In the case of ESS, the 11 non-host members are spending roughly 70% of their contributions in the form of in-kind contributions. The 2 host countries, Sweden and Denmark, are paying all in cash. And overall, that means roughly 35% of the facility is being constructed with in-kind contributions, which is just about manageable. In some other projects, such as ITER, the thermonuclear experimental reactor in southern France, the in-kind share is close to 90%, and that's very, very hard to manage. Modern expectations for a research infrastructure must also be addressed. In the case of ESS, that means caring about our CO2 footprint with a green construction site, renewable electric power, and using the Lund district heating system to dispose of waste heat from the electrical machines and the particle accelerator. We'll provide all of our data through the European Open Science Cloud in a way that is open and fair in the sense of findable, accessible, interoperable, and reusable. And that means that ESS data will not simply be used by the scientists who have generated it, but will be free to be used by anybody else after an initial period of 3 years of exclusive access. And we also need to think about spin-outs and maximizing the innovation impacts, and a science and innovation campus between ESS and the MAX 4 light source will be devoted to facilitate this. So ESS has developed a business case over 10 years ago. Ground was broken for the facility in 2015, and the project is now, as I said, 75% complete. So it's a good time to ask, how has this business case withstood the test of time? I think the science case is still strong, perhaps stronger now than it was in 2009. Materials and energy storage and drug development remain as topical as ever, and maybe even more so, given national commitments to become carbon neutral and given the special interest now in infectious disease. Neutron scattering facilities are being heavily invested in other regions, notably the United States and China. So I think we can be confident that this kind of investment is timely. Like any big infrastructure, there have been budget and schedule challenges at ESS, notably due to a post-Fukushima tightening of radiation safety requirements. issues with the in-kind supply chain that I mentioned earlier, and of course, in the past year, the impact of COVID-19, which has introduced some delays and extra costs. But financial commitments from the partners remain strong. And in particular, there's an additional 800 million euro commitment to commissioning and initial operations up to 2025 now in place. You can imagine the challenge of going and asking for this additional funding before ESS has yet delivered any science. And that was, of course, not straightforward. But that commitment from the member countries is a measure of strong commitment to ESS. In-kind commitments are successfully being delivered and integrated in Lund right now. And we've carried out an initial assessment of the economic impacts during the construction phase, which bears out the promises that were made in the original business case. And I will give a case study presentation in session C, which you can see for more details on that. So that's all. Thank you very much for your time and interest, and thanks.